Welcome students, this is the 13th lecture of our math series, that is the logarithms. If you have clicked on this video, then you have the basic idea about the exponents and powers. If you don't know about exponents and powers, you can check my previous videos, that is lecture number 9 and 10 on exponents and powers before moving on to this video. So talking about logarithms can be realized as the other side picture of exponents or powers, or the extension of exponents and powers. Logarithms were introduced to ease the mathematical calculations. I shall be showing you how. Now revising exponents, a to the power n equal to k can be written as a into a up to n times equals k, where a is base, n is exponent, and k is the value of a to the power n. Now logarithms are defined as the power to which the base must be raised to yield the given number. Now talking about the different terms of log expression, log m equals k, it is read as log to the base a of m equals k, where m is called argument, a is base, and k is the value of log m called power. Now let us we have a equation a to the power n equals k, and log is defined as the power to which base must be raised to give a required number. Thus log of k to the base a equals n. Thus, we can conclude that the exponential and logarithmic equations are equivalent. Any equation a to the power n equals k is same as writing log to the base a of k equals n. Here we have to note that the logarithms are defined only for the positive numbers. That is, the argument of a logarithm is always positive, and the base of a logarithm can be positive number only. Let us evaluate logarithms. Log to the base 10 of 100. Now according to the definition of logarithm, this must be equal to the value that must be raised to the base 10 to yield the value 100. As we know that 10 square equal to 100, thus log to the base 10 of 100 equals 2. Now in another example, let we have log to the base 2 of 8. Now we have to find a value that must be raised to the base 2 to yield the value 8. As we know that 2 cube equals 8, thus log to the base 2 of 8 equals 3. Here are some more other examples given here too. Please go through it, and if you have any doubts, ask me in the comment section. Now since the base of a logarithm can be any number, there are two special cases. When the base of the logarithm is 10, we call it as common logarithm, and when the base of logarithm is e, that is the exponential, we call it as natural logarithm and is denoted as ln. Here e, the exponential, is a mathematical quantity whose value is equal to 2.7182. Now since you have the basic idea about logarithms, let's see how they help in easing the mathematical calculations. 64 and 32, then 64 multiplied by 32 equals 2048, and 64 divided by 32 equals 2. But there is one more method to find this product and division. Since we know that 64 equals 2 to the power 6 and 32 equals 2 to the power 5, thus 64 multiplied by 32 equals 2 to the power 6 multiplied by 2 to the power 5, and using the exponent clause we can write it as 2 to the power 11. And similarly for division, 64 over 32 equals 2 to the power 6 over 2 to the power 5, which is equal to, using the exponent clause, 2 to the power 1. And now if we have a table for the values of 2 to the powers, then we can easily write for the values of 2 to the power 11 and 2 to the power 1 as our solution. Thus here the long mathematical calculations for multiplication and division are reduced to simple calculations for addition and subtraction using the exponent clause, and the logarithm works in the same way because logarithm gives us the powers, that is, it deals with powers. Now since you know about the logarithms, let us have a look at the identities of logarithms. I am just mentioning the identities here. I shall be covering their proofs in a separate video lecture. The first identity is log mn to base a, and is equal to log of m to base a plus log of n to base a. If we have more than two terms, then log of m into n into p up to r terms is equal to log of each of the terms, log of m plus log of n plus p plus up to r terms. Now the second identity is for division of terms. Log of m divided by n to base a equals log of m to base a minus log of n to base a. The third identity is log to the base a of m to the power n equals n times the log of m to the base a. Note that here n can be fraction too, that is log to the base a of m to the power p over q equals p over q times the log of m to base a. Now the fourth identity is change of base rule, which is equal to log of m to base a equals log of m to another base b divided by log of a to base b. So this is all about the identities of logarithms. In the next video lecture I am going to cover some questions based on these identities and tell you something about the concept of logarithms and anti-logarithms. Thank you. If you have any doubts or suggestions, do ask me in the comment section. Thanks.